R.D. Sharma Solutions, Class 12, Chapter 19. We are taking exercise number 19.16, Indefinite Integrals. Now we have this x square dx divided by x raised 6 minus a raised 6. This x square will come from x cube, that you already know. That means the differentiation of x cube will yield x square, and we have x raised 6 also. That can also be made up by x raised 3. So x square dx, which is the numerator, and denominator I am writing x raised 6 as x raised 3 whole square, minus a cube. A6 can be written as a to the power 3 to the power 2. We are taking t equals to x cube dt by dx, that is the 3x square, which is already there with the numerator. So in order to make the perfect numerator x square dx, we have to make this as dt by 3. So how the integration will proceed? See, x square dx, we will replace it by dt by 3. So 1 by 3 come here, dt comes here. X raised 6, that is x raised 3 to the power 2. So that is why it's t square. A to the power 6 can be written as a raised 3 2 square to the power 2. Now you know the formula of 1 by x square minus a square. This dx by x square minus a square is 1 by 2a log x minus a divided by x plus a inside the modular sign plus constant of integration. Please remember, x equals to t you will take to put it in the formula, and a will be taken as a cube. So wherever x is there, put t, wherever a is there, put a cube, and use this formula which I just mentioned. So 1 by 3 was already there outside. 1 by 2a, a is a cube here, so 1 by 2a cube. Then log x minus a, t minus a cube divided by t plus a cube. So you have to do that, but I'm just trying to make things easier for me. I'm not writing t because it will be t minus a by t plus a. Let us write it only. T minus a cube by t plus a cube plus constant of integration. T we have to replace finally by x cube. So this will become 1 by 6a cube. Then you have log modulus t will be equal to x cube minus a cube divided by x cube plus a cube. This is in the modular sign plus constant of integration. So this is the result I was talking about. X square which you have got from x cube, if you can understand and recall that x cube can give you x square, all other things will be quite easier to you. One more thing is there, 1 by x square minus a square formula also needs to be recalled here. Now this is very straightforward now. So let me just show you, because it's just x raised 3 you have to take as t, and the formula is also easy. 1 by x square plus a square will come when you will be solving this question. So in between you have to write this 1 by a tan inverse x by a. This formula you can use, and x cube equals to t is what we have done in the previous question. So just do this question like this. 1 by x, x raised 6 plus 1. So this is a different kind of question, because x raised 6 cannot give you x. How will you make it as x raised 6? So the better way is that x cube you can make it as x cube to the power 2, but that will not solve our purpose, because numerator we need at least x square so that we can get it from x raised 3, or you need some x raised 5, because when you differentiate x raised 6 it will be x to the power 5, it will come. So what we'll do here is we'll multiply numerator denominator by x raised 5, and when we multiply this x raised 5, what are we going to get? See, this is x raised 5, then you have x here. X raised 6 plus 1 was already there. I just multiplied numerator denominator by x raised 5. You will see what will happen. See, when you put x to the power 6 as t, you will get x raised 6. How about the denominator? X into x raised 5 has come, so you can just combine them and call it as x raised 6. So x raised 5 dx, and in the denominator you have x raised 6 and x raised 6 plus 1. And we know the integration of this one also. If we can place that, t plus 1 will come. So x raised 6, I am placing it as t. dt by dx will give you 6x to the power 5. So dt by 6 will be x raised 5 dx, which we have tried to get in the numerator. So let's write this. Dt by 6, it will be 1 by 6 will be outside the integration sign. Since x raised 6 is t, it will be t plus 1. Now t into t plus 1 will become t square plus t. That means when they take this t square plus t, because t into t plus 1 is simply, you multiply it. T into t is t square and t into 1 is t. So what we are going to do, we have to use the partial fraction, or you can make it as a perfect square. That is also possible. So since t has 1 as the coefficient, we have to divide this 1 by 2, then we have to square it, and then add and subtract this to the original equation for which we are attempting to make it as a perfect square. So 1 by 2 whole square minus 1 by 2 whole square. So a plus b whole square we are getting. T plus half whole square is t square plus half square plus t, which is already there in this which I am talking about, the first three terms. And the last term, which is negative half whole square. So now this 1 by 6 we are going to just deal it for a while. And other things, what we are trying to do is, this dt by t into t plus 1 has become now dt divided by t plus half whole square and minus half whole square. Now this integration of 1 by x square minus a square we already know. We have been doing question for this. 1 by 2a log x minus a by x plus a inside the modulus sign is important. So what is a here? What is x? X is t plus 1 by 2. So you will ask why you are not putting this t plus half as something. Don't worry. dt, if I place t plus half as some p, dt and dp will be equal, so there will be no change. So we'll take this a as half and the x as t plus half. So we'll get 1 by 6 already there. 1 by 2a, 1 by 2. What is a? Half here. Then log x minus a by x plus a. What is x minus a? X is t plus half. Minus a means minus half. T plus half minus half. Denominator will become t plus half plus constant of integration. Now this gets cancelled. 1 by 6 remains there. Then we have log half minus half will be 0. So t divided by t plus half plus half. Half and half will become 1. So this will be t plus 1. So this will be plus constant of integration. And what was x initially? X, it was t initially, x raised 6. Now replace it. 1 by 6 log x raised 6 divided by x raised 6 plus 1 plus constant of integration. That's your final result. So this is symmetry also. Okay, this is the way you are going to write it. This is for your reference, because how to solve is also important. Also with knowing that we are solving it with certain approach. Now this x square will give you x directly. So this t equals to x square. Dt by dx will give you 2x. That is, if you want to formulate x dx, which is the numerator, dt by 2 can be written in place of this. So t is equal to x square. What will be x raised 4? It will be t square. So this integration will become, this x dx will be dt by 2. Dt will come here. Half we can take it outside. x4 will be t square. X square will be t and plus 1. Now in this expression t square minus t plus 1, we'll try to make it as a perfect square. What is the approach? We'll take the coefficient of the middle member, which is t or x it was. They make it half, square it and add it and subtract it. So half square minus half square. Now what is the benefit of doing this? We can get a square plus b square minus 2ab. So this will be a minus b whole square, t minus half whole square. Then we have plus half square also. We have 1 also and negative half also. So 1 minus 1 by 4, it will be 3 by 4. Now we have to square it. 3 by 4 has to be squared. So what will be the square of, how will you make that 3 as a square? First make an under root and then square it. The best thing is make under root for all the terms, which is numerator, denominator. And you see under root 4 will release 2 out. So that will be root 3 by 2 whole square. So the integration of 1 by x square minus a square, x plus a square plus a square it is. 1 by a tan inverse x by a, dx by x square plus a square. There is no, I have not written a square, it is a square actually. So we will put x as t minus half and a as root 3 by 2, and we'll use directly 1 by tan inverse x by a formula. Half was already there if you remember. 1 by a, what is a? Root 3 by 2. It will not be twice, I'll just cancel it out. It's not 1 by 2a, 1 by a tan inverse x by a. So I'm just cancelling it out. Tan inverse x by a. X is what? T minus half. And what will be a? It will be root 3 by 2. So this 2 gets cancelled. 1 by root 3 only will remain. Then the 10 inverse. Then t minus half divided by root 3 by 2. This t minus half will become 2t minus 1 divided by 2. Root 3 by 2 is already there in the denominator. 2 will get cancelled. 2 minus 1 by root 3 will come. Now this 2t minus 1 by root 3, this t can be replaced now by what was taken as t, remember? It was x square. So 2x square minus 1 by root 3 it is. I have not written root 3, it is root 3. So this will be 2x square. So this all, you have to do it step by step, because I just try to divide and conquer, try to tell you every aspect wherever we are using what. Alright, it will be 2x square minus 1 by root 3. Please remember, it's not 3, it's root 3. There is a slight change here. So this is how you are going to go about it and solve it. This is the final solution for this question. Now this x by 3x raised 4 minus 18x square plus 11 x square will directly give you this x. So when you take t equals to x square, dt by dx will be 2x. So dt by 2 will be equal to x dx. So this term will become like this. X dx will be dt by 2. Dt will remain like this. 1 by 2 will come here. In the denominator it will be 3. X raised 4 will be t square. When you square, x square square will be t square. 18t will be there plus 11. Now we will make it as a perfect square. So first thing we'll do is we'll just take this 3 out. When you take 3 out, divide everything by 2. So 3t square by 3 will be t square, minus 18t by 3 will be 6t, plus 11 by 3 will remain there. Now this 6 will be divided by 2, it will be 3. Then we square it and add and subtract. So plus 9 and minus 9 will do. So a square plus b square minus 2ab is t minus 3 whole square. What is remaining here? 3 was already outside. 11 by 3 minus 9, and that is 11 minus 12. 9 is 27 by 3. 11 minus 27 is negative 16 by 3. Negative is already there, so negative 16 by 3. So we'll have to make it as a perfect square. 16 by 3. 16 is already 4 square. 3 square, that is under root 3 whole square. Now this denominator, if you remember, 3 was already there. 1 by 2 is already there. So 1 by 3 into 2 will be 6. dt divided by t minus 3 whole square minus 4 by root 3 whole square. Now if you remember, x square minus a square, what was the integration? 1 by 2a log x minus a by x plus a, that comes inside the modular sign plus constant of integration. A you have to take here as 4 by root 3. You have to put it in the formula, right? X you will take it as t minus 3. Let's apply the formula. 1 by 6. 1 by 2a. 1 by 2 into 4 by root 3. A was 4 by root 3. Then log. What was x? It was, I'm doing it here so that we can replace it directly in the answer. Let me tell you the nitty-gritties here. T minus 3 minus 4 by root 3, that is x minus a. Then x plus a. T minus 3 plus 4 by root 3. T minus 3 minus 4 by root 3. T minus 3 plus 4 by root 3. Don't worry, just keep it as 3 minus 4 by root 3. Don't need to solve it. Okay, you can solve it, but there is no point. The answer is perfect. Only one replacement is necessary. T has to be replaced by x square, which was initial, because we imagined it. So this will become log x square minus 3 minus 4 by root 3, x square minus 3 minus 4 by root 3, and then we have x square minus 3 plus 4 by root 3. So this will be inside the modular sign plus constant of integration. Let me change the first thing. 6 into 2 into 4 by root 3. Root 3 will go up. This will be 4 to the 8, 6 8 is 48. Root 3 by 48 it will come. So the final answer will be root 3 by 48. This content, and then same thing, log plus constant of integration, that thing. So this is the solution which I am presenting in front of you, which is for your reference. You have to make this as a perfect square. Once you are able to make it as a perfect square, then you have to use the formula of 1 by x square minus a square. Now people will ask, why haven't you equated t minus 3 as some p? Because dp equals to dt will come. So there will be no change. Next one is e raised x by 1 plus e raised x, then 2 plus e raised x. So this is very straightforward because ex differentiation, e raise integration, always e raise x will come, e to the power x will come. So if you take t equals to ex, dt by dx will be equal to e raise x, dt will be equal to e raise x dx. So in the integral terms, you can write integration of dt by 1 plus t, which is 1 plus e raise x, and 2 plus t, which is 2 plus e raise x. So you have to do it using the partial fraction. If you are not able to recall the partial fraction, I can tell you a simple way to do this, because 1 plus t and 2 plus t are simpler. But if you happen to get these 1 plus t, 2 plus t and other members, say it would have been 3 plus t also, 3 terms, then you have to do it very carefully. So what we'll do here is, we want 1 plus t and 2 plus t in the numerator. So I'm just keeping it 1 plus t plus 2 plus t, but there is 1 in the numerator. That is 1 into dt. We need to get 1. So what we'll do here is 2 plus t minus 1 plus t will give you what? T minus t will be 0 and 2 minus 1 will be 1. So you will get a 1 here. So this 1 can be written as 1 plus t plus 2, which we tried earlier, which I failed. Now 2 plus t minus 1 plus t has perfectly worked. So this 2 plus t and minus 1 plus t is actually written just to eliminate the denominator one by one, and then get an easier simplified result so that we can integrate it properly. So now just separate this 2 out, 2 plus t divided by 1 plus t into 2 plus t. This will be the first term, 2 plus t divided by 1 plus t and 2 plus t, minus integration of 1 plus t divided by 1 plus t into 2 plus t. Now you can just cancel these terms, 2 plus t, 2 plus t, 1 plus t, 1 plus t, you can cancel. So this is dt divided by integration of 1 plus t actually we are doing. Here also integration of 2 plus t we are doing, 1 by 2 plus t. And these are simply log. Log 1 plus t will come, inside the modulus sign will be there. And log 2 plus t. And you know log a minus log b is what? It's log a by b. So that we will use here. Log 1 plus t minus log 2 plus t will give you log 1 plus t divided by 2 plus t. So log a minus log b will be log a by b, which is log 1 plus t by 2 plus t, plus constant of integration. But what was t earlier? Actually e was e raise x only. Now you can do this or write this in a different form. Log, inside the modulus you will have 1 plus e raise x, denominator 2 plus e raise x plus constant of integration. That's your final result. So this is how you can do this, all of it. We have used this as a partial fraction